So in this video, I wanted to do a problem involving two proportions. So the problem reads, in a study of treatments for very painful cluster headaches, 146 patients were treated with oxygen and 145 other patients were given a placebo, consisting of ordinary air. Among the 146 patients in the oxygen treatment group, 123 were free from headaches 15 minutes after treatment. Among the 145 patients given the placebo, 39 were free from headaches 15 minutes after treatment. Use a 0.05 significance level to test the claim that the oxygen treatment is effective. All right, so let's see what we have here. So it's always a good idea to be organized. So we're going to look at what we have for sample 1, which is the treatment group. And then look at what we have with the sample 2, which is the placebo group. So for sample 1, N sub 1 is 146 patients. X sub 1 represents those in the first sample who were free from headaches, and that was 123. For the second sample, N sub 2 is the sample size for the second sample, those who received the placebo. So in that case, 145. And X sub 2 are those in the second sample who were free from headaches. So in this case, 39 were free from headaches. All right, so once we have all of this, we can then identify, we can proceed. So let's identify the null and the alternative. So the claim, we usually should start with the claim. So the claim is that the oxygen treatment is effective. So because this is involving two proportions, we're going to compare P sub 1 with P sub 2. All right, so if the oxygen treatment was effective, remember P sub 1 represents the percentage of, or the proportion of those who were free from headaches for the oxygen group, right, the treatment group, and then P sub 2 represents those who were free from headaches with the placebo group. So to say that the oxygen treatment is effective, that would mean that P sub 1 is greater than P sub 2. This percentage or proportion of those who are free from headaches in the treatment group is greater than those in the placebo group. All right. So the null is a statement which states that there is no change or no difference between the two groups in this case. So that would be P sub 1 is equal to P sub 2. And then the alternative says that there is a change. So in this case, we're going to adopt the claim because the claim is a statement of change. So P sub 1 is greater than P sub 2. All right, so the correct answer for this would be choice D. Okay, and then here we're going to use a p-value method to test this claim. So the p-value method, we're looking to obtain the test statistic and the p-value. Okay, so for that, we're going to use our calculator. So I'm going to pull up the calculator here. And we're going to use, because this is involving two proportions, we're going to use a function called 2prop_z tests. So we're going to go to 2prop_z test for two proportion z tests. And x sub 1, n sub 1, and all of those good stuff is right here, right? So let's put those in. So x sub 1 is 123. 146 is n sub 1. X sub 2 is 39. N sub 2 is 145. And this is the alternative. So the alternative is greater than. So I'm going to press right to there and press enter, calculate. So we have our values. So this is the test statistic. This is the p-value. So the test statistic is 9.85 rounded to 2 decimal places. And the p-value is not 3.61. Again, this is not a valid probability values. Value probability range from 0 to 1, right? So, but if you look here, it says e to the negative 23. So we're going to take this decimal point, move it 23 times to the left. If we round to 3 decimal places, practically 0, right? Okay. So once we're here, once we get the p-value, we're going to compare the p-value with alpha, the significance level. So the p-value compared to alpha, p-value is 0. Alpha is up here is 0.05. So let's see. 0 is clearly smaller than the p-value. So when the p is low, we reject the null. So in our conclusion here, um, the p-value is less than the significance level alpha. So we reject the null hypothesis. Anytime we reject the null hypothesis, there is sufficient evidence to support the claim. Okay, so once we have that, let's look at the second method. So the second method is the confidence interval method. So in this case, because we're dealing with two proportions, the function we're going to use is called 2prop z int. So for 2 proportion z interval. All right, and also take note the confidence level is a 90% confidence interval, so confidence level is 90%. Again, we're estimating the difference between p sub 1 and p sub 2. So let's see how that looks. So I'm going to take a look at the calculator, and we're going to go to stat, go to test, go to 2prop z int. So that's the function, press enter. All of those values which we put in for 2prop z tests, they transfer over, so we don't need to change those values. Again, if you just kind of recall, these values transferred over. The only thing we need to change is the confidence level. So the confidence level, we'll back up here, 90%. So we're going to go down here, change this to 0.90, and then calculate. So here's the lower bound, here's the upper bound. So let's write those values down. So the lower bound is 0.495, and the upper bound is 0.652. So 0.652. Okay, so this interval is estimating the difference between p sub 1 and p sub 2. So the difference between those two proportions ranges anywhere from 0.495 to 0.652. So in this interval. So from here, we want to identify, well, where is 0 relative to this interval? So 0 is to the left. It's somewhere over there, right? Why do we locate 0? It's because if the difference between p sub 1 and p sub 2 is 0, then if you guys recall, then that means there's no significant difference. But in this case, 0 is not included in this interval, so that would mean that there is a significant difference between these two proportions. Again, these two proportions, they represent the percentage of those who were free from headaches, right? In the first group, the treatment group versus the placebo group. So since there is a difference between the two, we answer the following. It says, because the confidence interval limits does not include 0, right? Doesn't include 0. This highlighted part does not include 0. It appears that the two cure rates are different. Because the confidence limit intervals include positive values only, right? Positive values. These are all positive values in here. It appears that the cure rate is greater for the oxygen treatment than the placebo. Now, what that means, again, greater because if you guys recall, if p sub 1 minus p sub 2 is greater than 0, then p sub 1 is greater than p sub 2. All of these are positive values, so p sub 1 must be greater than p sub 2. All right, so hopefully that makes sense. If you have any questions, again, shoot me an email.